Okay, let's talk about the region first. And I'm going to get a little better at this now, I think. And the first thing I notice is that it's x equals 0. And x equals 0, basically just the y-axis. And x equals y is just a simple line like this with a slope of 45 degrees. All right? And then, the y equals 0 and y is 4. So I'm going to say it's a region up here. All right? Now, before I go on, I don't know if I really need that, but I can visualize the region they're integrating over. What I want to do is look at the integration, and I want to just simply say, could I integrate that? And I can. And at least I think I can. Oh yeah, look at that. So let's put this down. I'm looking at this over here. I'm going to write it aside for you, though. And one thing I can pull out a 2, and I can pull out y plus 1. And what am I left off with? I'm left off with 0, y over 1, x plus 1 dx. And I can definitely integrate that. What do you get? 2 over y plus 1 times, that guy's antiderivative is a natural log of the absolute value of x plus 1. All right? So what do you do now? The limits of integration out are going to be 0, y. I can write that down. And what do you get? You get 2 over y plus 1 times the natural log of the absolute value of y plus 1. And the lower limit, if I did that, again, this is the x value, I just plug it in, so it's minus 2 over y plus 1. And then you get what? You get, let's see, it would be plugging into 0, so you just get ln of 1. Well, that's 0. I'll just throw that away, all right? So I also get rid of the absolute value symbol, because again, if you remember my region's over here, and the y's are above, certainly y plus 1 is above 0, all right? So let me put that down, and I can put 0 to 4, and then it's going to be the natural log. Put the 2 on the outside. The natural log of y plus 1, no need for absolute value, over y plus 1, and then it's going to be dy. Can I integrate that? Well, let's give it a try. And one thing I'm going to do is u substitution. U equals y plus 1, and then du would equal dy. So I get 2. If y is 0, u would be 1. If y is 4, u would be 5. And then I get the, again, be careful about it. I don't think that's good substitution. Let me back away from that. That's not really helping me out. Let's try a different one. Let's try u equals the natural log of y plus 1. Du would be 1 over y plus 1 dy. That works much better. Let's try that. What do you get? 2. Well, if you get 0, the lower limit would be the natural log of 1, which is 0. And the upper limit would be the natural log of 5. Let's see, you get u, du. Relatively simple. What do you get? 2u squared over 2, evaluated from 0 to ln 5. What do you get there? Well, the 2's cancel, so you're going to get the natural log of 5, quantity squared. And if you put a 0 in there, you just get a 0, so I'm not going to write that down. So I'm going to call it quits there, box that, and I do want to look at the k and see if they've got that. And they do. They wrote it a little bit differently. I would tend to write it this way over here, not to confuse anyone, but this way I would write it down. I think a lot of textbooks would write that down over there. But anyway, it was easy to do, kind of a trivial problem. Thank you.